Hello everyone, my name is B.Tech+M.Tech. Before starting main chapter of physics, we always complete basic of mathematics. Why we complete basic of mathematics before physics? Because we will see that some basic mathematics, some concept of mathematics is required to solve the physics problem. Okay, so if you know that concept, then easily we can solve physics problem. Like differentiation is required, integration is required, some trigonometric concept will be required there, logarithmic required there. So that is the reason we study this basic of mathematics that we call also mathematical tool. So basic of mathematics is required before physics chapter. Okay, so that is the reason we are going to complete first basic mathematical tool. Okay, so why we call it mathematical tool? Because we will use mathematics as a tool. We will use mathematics as a tool to solve the problem of physics. That is the reason we have given here some name like mathematical tool. This is not mathematics, this is mathematical tool. Mathematics means we will study all about mathematics. Okay, that is very vast. Here we will study just basic concept of mathematics which is required in physics. Okay, which is required in physics. Okay, we are not going to study all mathematics. So here we can write why we call it mathematics, mathematical tool, because mathematics we will use mathematics as a tool to solve physics problem. That's why we call it, that's why we call it mathematical tool. Okay, so mathematical tool is something like used to assemble or disassemble the machine. Okay, so tool is something like acting like a helping hand. So here mathematical tool means this mathematics will act like a helping hand to solve the problem of physics. That's why we have given name mathematical tool. Okay, so in mathematical tool section we will study about trigonometry. Here main part will be first one trigonometry, first trigonometry, second we will study function, third algebra, fourth graphs. We will also study about logarithmic, and sixth one, which is very important, differentiation, and next integration. Mainly differentiation, integration is important here, but we'll study that one also. And last one we'll study vector also, because from the first chapter of physics, like from straight line, we will see vector application. So we'll complete vector first also. Okay, so this much topic will complete. Okay, in basic mathematics, trigonometric, function, algebra, graphs, logarithmic, differentiation, integration, as well as vector also. Okay, so today we will complete first one, trigonometric. Okay, actually it will be one 1.5 hours, around 2 hours. 2 hours will be required for each chapter. This will take slightly more. Okay, so within 2 hours we'll try to complete one chapter. Okay, in just 2 to 3 video. Okay, so today we are going to study about trigonometric. What is trigonometric? How trigonometric is defined? Basically, this is a relation between. We can define it. It relates angle and sides of a triangle. Okay. So trigonometric means it relates angle and sides of a triangle. Okay. So here angle term is coming. Let's understand what angle is. Angle, if I want to define angle, so this angle is 2D angle. This is represented by theta. So to define this angle, let's take here one line. Let's say take this one is A and B. Now this is fixed. Okay. You rotate this one. Okay. This is fixed. So if you rotate this one, then it will form a circle here. Okay. Let's say after some time this point B is shifted to this one. Let's say this one is C. Okay. You connect this one. So this one, this length you treat as a radius because this is a circle now. So this length will be a radius. Now this angle is theta. Okay, I'm giving name. Okay, this angle subtended. This angle is, let's say, theta. Then this angle theta is defined as arc upon radius. Arc upon radius. What is arc here? Arc means this AB is, this B is shifting to C point. So this BC is arc. Okay. So this one is arc, and this arc is, we will write it like this. BC. Arc means we will write like this. Okay. So this is arc BC upon radius is arc. Okay. So this is how angle is defined. Now unit of this angle is radian. Unit is radian. In shortcut, we will write always RAD. Okay. So unit of this angle is radian, and this is defined as arc upon radius. Okay. So now, if this will move one round, one complete round. Okay. So in one complete round, this B will again come back to the same point. Okay, so in one complete round, this arc with BC will be equal to, I will not write it BC, just one complete round, this arc will be equal to 2 pi r. Okay, one perimeter. So in one complete round, arc will be 2 pi r. Okay, because one complete round it will move on circle. Okay, one perimeter, and that one perimeter is 2 pi r. So angle theta will be, let's say I'm saying this is maximum angle. Okay, so because this is one round, one complete round, so this will be maximum angle. So this value will be 2 pi r upon r. This is equal to 2 pi, and this is radian. So maximum angle possible is 2 pi radian. Okay, because in one complete round, maximum angle covered here, that is 2 pi. Okay, so now for our convenient, we will divide this 2 pi angle. For our convenient, we have divided 2 pi radian angle into 360 parts, and one part is named as 1 degree. 1 degree. So we can write here 1 degree equal to 2 pi upon 360, because 2 pi radian is divided into 360 part, and one part is named as 1 degree. Okay, so 2 pi upon 360, that is 1 degree, and we write it like this. Okay, 1 degree, representation of degree is like this. Okay, 1 degree. So this 1 degree is, we are getting here pi upon 180. So we are getting here one formula also, that 1 degree equal to pi upon 180 radian. Okay, this is conversion formula we are getting here. Similarly, if I want to write 1 radian equal to in degree. So we can write here 1 radian, that would be equal to 180 upon pi, and this will be in degree. So we can write this formula also. So we are getting here two formula to convert degree to radian and to convert radian to degree. This is also known as conversion formula. Conversion formula. So this is how you can convert radian to degree. Okay, that means one thing here you have to remember, that if you want to convert degree to radian, then what you have to do? You have to multiply 1 degree equal to this much radian. So let's say x degree there. So x degree equal to x into pi upon 180. That means you have to multiply pi upon 180. So note, to convert degree to radian, multiply by pi upon 180. That's all. And similarly, if you want to convert radian to degree, multiply by, if 1 radian equal to this much, let's say x radian. So x radian means you have to multiply x into 180 upon pi. That means multiply by 180 upon pi. Okay. So this is what you have to remember. 1 degree equal to this much radian, and 1 radian equal to this much degree. Okay. So this topic is over. Now we can convert angle to radian or radian to angle. So let's solve one question based on it. Okay. Okay. Convert degree to radian, like 30 degree, second, 60 degree, third, 90 degree, and fourth, let's say 120 degree. Okay. So here, if you want to convert degree to radian, so what would be answer here? Answer would be 1 degree equal to, we know that 1 degree equal to this much radian. So 30 degree equal to 30 into how much? This 30 degree equal to, we can write directly here, 30 degree equal to 30 into pi upon 180, that is radian. So we can write this value is pi by 6 radian. Okay. So this is how we can convert this one also. What you have to do? Only you have to multiply here by 1 pi upon 180. Okay. So this value will be pi by 3 radian. This one again 90 into pi by 180. So this will be pi upon 2 radian. Okay. So only you have to multiply by pi upon 180. So this is 180 into pi upon 180. This value will be 2 pi upon 3 radian. Okay. This is how you can convert. So second question, if you want to convert radian to degree, so convert radian to degree. So first, let's say pi by 3, second pi by pi by, let's say, 4. This is third, 2 pi by 3. Okay, so you can convert this all are in radian. Okay, this is radian. So now directly I'm writing here. So pi by 3 radian. So what we have to do, if you want to convert radian to degree, so multiply by 180 upon pi. So multiply by 180 upon pi. This value will be 60 degree. This value will be pi by 4 into 180 upon pi. So this is pi cancel, and we will get here 45 degree. This will be 2 pi by 3 180 upon pi. So this value will be 120 degree. So this is how we can convert radian to degree and degree to radian. Clear? So next one is trigonometric ratio. Next one is trigonometric ratio. How trigonometric ratio are defined? So trigonometric ratio. Trigonometric ratio means here we will take here right angle triangle, and we will write ratio of sides of triangle. We will first you complete this one. Okay. Okay. So now trigonometric ratio. How trigonometric ratio is defined? We will take here right angle triangle. In right angle triangle, we will take ratio of two sides of this right angle triangle. So ratio of two sides of right angle triangle will be a constant value. A constant value means if I take here, this is right angle triangle. This is I'm taking AB upon BC or BC upon AB. So this is two pair. Okay. Similarly, BC upon AC or AC upon BC. This is also true. Similarly, AB upon AC and AC upon AB. This is also true. So we can take here 6 ratio. Okay, and we will give there 6 name. Okay, so that value will be for particular angle. That value will be a constant. Like if I am taking ratio of sides of a triangle, so I am taking here this one is 90 degrees. So this one will be hypotenuse. This one is hypotenuse. This one is perpendicular. For this angle, this will be perpendicular. Okay, if you take this angle, then this AB will be perpendicular. This will be base. Okay, so in shortcut we will write it base, perpendicular, P, hypotenuse, H. So this is right angle triangle. Now if I am taking ratio perpendicular upon base, so perpendicular upon base I am taking, then I will call it perpendicular upon hypotenuse. Wait. Perpendicular upon hypotenuse I am taking, then I will call it sine theta. Okay, so always in right angle triangle perpendicular upon base is written as sine theta. So we are introducing here new name, that this upon this ratio is sine theta. Okay, so for this angle this will be perpendicular, this will be hypotenuse. So if this side is bigger, this hypotenuse will be also bigger. Okay, so for particular angle, okay, so particular angle this upon this will be a fixed value always. Okay, and this is in shortcut I will write sine theta equal to P upon sine theta equal to perpendicular upon hypotenuse. So this formula you have to remember. This formula is very important. Similarly, if I am taking base upon hypotenuse, base upon hypotenuse, then this value is named here as a cos theta, and this cos theta is based upon hypotenuse. So this formula you have to remember here. Okay. Third one, if perpendicular upon hypotenuse, base upon hypotenuse. Third one, perpendicular upon base. So this is perpendicular upon base. This value will be known as tan theta. So ratio of perpendicular upon base is tan theta, and shortcut again we can write P upon this is base. Okay. So three formula we are getting. Similarly, if I take here hypotenuse upon perpendicular, so that will be 1 upon sine theta, and that will be named as cosec theta. So next one, if I am writing opposite of this one, so this, if I'm writing h upon p, so this will be 1 upon sine theta, and this is known as cosec theta. Okay. So next one, this formula. So better you remember this three one, and you remember that 1 upon sine theta is cosec theta, that much. So similarly here we can write h upon b, that will be 1 upon cos theta, this will be known as sec theta. And last one, this is b upon p, means base upon perpendicular, this will be 1 upon tan theta, and this will be known as cot theta. Clear? So these six formula we are getting here. Okay. So six formula, you remember these three are very important. Okay. So these are formulas. Okay. Sin theta, cos theta, tan theta. We are introducing here ratio of side of a right angle triangle. Okay. Next, complete this much. So here we will learn about for a particular value for a standard angle, what is value of sin theta, cos theta, and tan theta. So for particular angle, that means I will write here this is angle, and this is trigonometric ratio. In shortcut I will write T ratio. Okay. So this is trigonometric ratio. Okay. So here I am writing. Okay. Trigonometric ratio. Okay. So this one is angle. Okay. So trigonometric ratio and angle. So this is for standard angle, for standard angle T ratio, means trigonometric ratio. For a standard angle we are going to find out T ratio. Okay. So standard angle means this angle will be, if angle is, this angle is 0, then what is value of all sin theta, cos theta, tan theta, cosec, sec, and cot. So this is standard angle 0. Then next one 30 degree. Then next one 45 degree. Then next one 60 degree, and last 90 degree. Okay. So already you will study in 10th class also, but here once again we will revise it. Okay. So here T ratio, I will not write all 6, I will write only 3. Okay. Only 3. That means first one is sin theta, this is cos theta, this is tan theta. Okay. So if you want to find out cosec theta, you just calculate sin theta and take reciprocal of that one. Okay. So like sin theta means 0 angle. then what is value of sine theta? Means sine 0. Okay, so like if I put here 0, so of course this line will coincide with base AB. That means this line will coincide with base AB. So this C will coincide with B and this value will be 0. Okay, so this base, this perpendicular BC will be 0. That means BC will be 0. That means this perpendicular 0. So 0 upon anything is 0. So this is very standard that if angle is 0, then value of sine will be 0. Similarly, 10, 0. So 0 means this will coincide. So perpendicular will tends to 0. So in 10 also it will be 0. Cos will be 1 because cos formula is based upon hypotenuse. So if this will coincide with B, so base will not change and this hypotenuse will become equal to base. That means base and hypotenuse will be almost equal. So same base upon hypotenuse, both will be almost equal. So it will be 1. So that is the reason sine 0, 0, cos 0, 1, 10, 0, 0. Similarly, these are standard angle. If you put here 30 angle and always you measure this distance, okay, you increase the base and you measure what is perpendicular and hypotenuse, this ratio will be same. If angle is fixed 30 degree, so that fixed 30 degree angle, we always get this value 1 by 2. So you have to remember this value, okay. So this is 1 by 2, this is 1 upon root 2, this is root 3 upon 2, this is 1. This is root 3 upon 2, this is 1 upon root 2, this is 1 upon 2 and this is cos 90, 0. Similarly, here 10, 0, 0, 10, 30, 1 upon root 3, this is 45 1, this is root 3 and this is basically 10 theta is also sin theta upon cos theta, okay, sin theta upon cos theta. So when I will write here 1 upon 0, so it is not defined exactly. If at 10 90 this is not defined, but close to 90 you can also say infinity. So mostly you will see infinity also, but exactly at 90 degrees this is not defined or not defined. Okay, understood? So 1090 means if it is close to 90, then value will be infinity. Okay, but if it is exactly 90, then 1 upon 0 is not defined. But close to 90, so this value will be close to 0. This is close to 1. So 1 upon close to 0, very small number, that will tend to infinity. So that's why this. Now, for higher angle like 120, 150 or any 200, 300, okay, any higher angle, okay, we will use by formula. We will calculate all higher angle value by formula. We will not remove any data. Okay, so this is standard angle T ratio. Now one very important point you can note here, very important angle which is mostly used in physics, okay, that if I'm taking here, right angle triangle, which side is 3, 4 and of course if it is 90, then 3 square plus 4 square will be 25, that is equal to 5 square. So I can write, if this is 3, this is 4, then this will be 5. If I'm writing like this, okay, if I'm writing like this is 3, then this is 4, this is 5. Okay, so if right angle triangle, so if two side base and perpendicular is 3 and 4, so hypotenuse will be 5, then this angle is very standard angle. You have to remember this value. Okay, higher, there are two angle possible only, 37 degree and 53 degree. Okay, so higher side means this angle will be higher angle, that means this is 53 degree. Lower side means in front of lower side this angle will be lower, that means this is 37 degree. Similarly here also you can write, okay, 37, 53, so this value smaller, so this angle will be smaller, so smaller means 37 degree. This value larger, so this angle larger means 53 degree. Okay, so these are angle which is very important. Mostly we'll see question based on it. Okay, so we can write here sin theta, cos theta, tan theta. So let's say what is value of sin 53? Take 53. 53 means 4 upon 5. 4 upon 5. What is cos 53? Cos 53 base upon hypotenuse. What is 10? 10 53. 10 53 is 4 upon 3. Okay, so 10 53 4 upon 3. Similarly, we can write for sine this 37 angle also. So for sine 37, this value will be 3 upon 5 cos 37. This value will be 4 upon 5 and 10 37 equal to, that is 3 upon, okay, so 3 upon 4. So sin 37 3 upon 5, okay, cos 37 4 upon 5, tan 37 3 upon 4. Okay, so this is very important. You have to remember this value. So better you don't remember value only, you remember this diagram. Okay, so what is this diagram? If sides are 3 4 5, then angle will be 37 or 53. Sin 37, okay, that means 3 4 5 side you write it, then smaller angle, a smaller side, smaller angle, higher side, higher angle, that much you write. Next you can easily write it. Okay, that sin 53, so perpendicular upon hypotenuse, cos 53 base upon hypotenuse, tan 53 4 upon 3. Okay, so this is all about. Okay, so in today's lecture this much is okay. Next lecture we will complete about higher angle T ratio. That means for higher angle, how to calculate this sin theta, cos theta, tan theta. Okay, and there are some more trigonometric inequalities. Okay, so we'll complete that. Okay, thank you so much.